When sizing a short circuit and ground fault protection device for a motor, understanding National Electrical Code Section 430.52 code is critical. This section addresses the selection of the correct fuse or circuit breaker to protect the motor from overcurrents and ground faults. The core of the question lies in exception number 1 of 430.52 code, which deals with situations where the calculated current value doesn't match a standard available rating for fuses or breakers. The code states that in such cases, the next higher standard rating may be used. This is where the confusion often arises, specifically whether or not using the next higher rating is mandatory. The answer is no, it's not mandatory. The code uses the word may, indicating permission but not a requirement. To illustrate this, consider a 30 horsepower, 3-phase, 208 volts motor. According to the information provided, the motor's full load current is 88 amps. When sizing the short circuit and ground fault protection, different multipliers are applied depending on the type of protection device. For dual element fuses, the full load current is multiplied by 1.75. In this case, 88 amps times 1.75 equals 154 amps. Now, examining standard fuse sizes, 154 amps isn't a standard rating. This is where exception number 1 comes into play. The next highest standard fuse rating above 154 amps is 175 amps. Therefore, a 175 amp dual element fuse could be used. However, it's also permissible to use a lower rating if it's deemed appropriate for the specific application. For inverse time breakers, the full load current is multiplied by 2.5. So, 88 amps times 2.5 equals 220 amps. Again, 220 amps isn't a standard breaker size. The next highest standard breaker rating is 225 amps. Thus, a 225 amp inverse time breaker could be used. As with fuses, using a lower rated breaker is allowed if the situation warrants it. While the code permits using the next higher standard rating, it's crucial to understand that it's not an obligation. Selecting the appropriate protection device involves several factors, including the motor's starting characteristics, the load it drives, and the available fault current at the installation location. Using the next higher standard rating generally provides a greater margin of safety against nuisance tripping caused by temporary overcurrents such as those experienced during motor starting. However, if the selected rating is too high, it may not provide adequate protection against smaller overcurrents, potentially damaging the motor. To make an informed decision, consider the motor's starting current. Motors draw significantly higher current during startup than during normal operation. This inrush current can cause nuisance tripping if the short circuit and ground fault protection device is sized too closely to the motor's full load current. Dual element fuses and inverse time breakers are designed to tolerate these temporary overcurrents without tripping, but it's still essential to select a rating that allows the motor to start reliably without sacrificing protection. Also, consider the load characteristics. The type of load the motor drives affects the amount of current it draws and the likelihood of overcurrent conditions. For example, a motor driving a pump may experience occasional surges in current due to changes in fluid viscosity or pressure. A motor driving a conveyor belt may experience overcurrents if the belt becomes overloaded. Understanding these load characteristics is crucial for selecting the appropriate short circuit and ground fault protection device. Additionally, consider the available fault current. The available fault current is the amount of current that would flow in the event of a short circuit or ground fault. This value is determined by the electrical system's characteristics, including the utility transformer size and impedance, the conductor size and length, and the grounding system. A higher available fault current requires a short circuit and ground fault protection device with a higher interrupting rating. The interrupting rating is the maximum amount of fault current the device can safely interrupt without failing. Selecting a device with an inadequate interrupting rating can lead to catastrophic failure in the event of a fault. In summary, while 430.52 current exception number 1 permits using the next higher standard rating for short circuit and ground fault protection devices, it's not a mandatory requirement. Selecting the appropriate device involves considering several factors, including the motor's full load current, starting current, load characteristics, and the available fault current. It's generally recommended to use the next higher standard rating to provide a greater margin of safety against nuisance tripping and to ensure adequate protection against overcurrents and ground faults. However, it's essential to evaluate the specific application and equipment before making a final decision. Now, let's delve deeper into the practical considerations for selecting the appropriate short circuit and ground fault protection. Firstly, consult the motor manufacturer's recommendations. Motor manufacturers often provide specific guidance on the appropriate short circuit and ground fault protection for their motors. This information can be found in the motor's nameplate data, installation instructions, or technical specifications. Following the manufacturer's recommendations is generally the best practice, as they have the most in-depth knowledge of the motor's characteristics and protection requirement. Secondly, perform a coordination study. A coordination study is a detailed analysis of the electrical system to ensure that the short circuit and ground fault protection devices are properly coordinated. This means that the devices closest to the fault will trip first, minimizing the impact on the rest of the system. A coordination study involves calculating the fault current at various points in the system and selecting devices with appropriate time current characteristics. Thirdly, consider using a motor protection relay. A motor protection relay is a sophisticated electronic device that provides comprehensive protection for motors. These relays can detect a wide range of fault conditions, including overloads, short circuits, ground faults, voltage unbalance, and phase loss. Motor protection relays offer several advantages over traditional fuses and circuit breakers, including more precise protection, adjustable settings, and communication capabilities. Fourthly, document the selection process. It's important to document the selection process for the short circuit and ground fault protection device, including the calculations, assumptions, and considerations that were made. This documentation can be valuable for future reference and troubleshooting. It also demonstrates due diligence in selecting the appropriate protection for the motor. Fifthly, understand the different types of fuses and circuit breakers. There are several different types of fuses and circuit breakers available, each with its own characteristics and applications. Dual-element fuses, also known as time delay fuses, are designed to tolerate temporary overcurrents without tripping. This makes them suitable for protecting motors with high starting currents. Inverse time breakers are designed to trip faster as the overcurrent increases. This provides better protection against smaller overcurrents. Instantaneous trip breakers are designed to trip almost instantaneously in response to a short circuit. These breakers are typically used for protecting equipment against severe fault conditions. Sixthly, consider the ambient temperature. The ambient temperature can affect the performance of fuses and circuit breakers. Fuses are typically rated for an ambient temperature of 25 degrees Celsius or 77 degrees Fahrenheit. If the ambient temperature is higher than this, the fuse may need to be derated. Circuit breakers are also affected by ambient temperature, but the derating factors are typically less significant. Seventhly, inspect and test the short circuit and ground fault protection device regularly. It's important to inspect and test the short circuit and ground fault protection device regularly to ensure that it's functioning properly. Fuses should be visually inspected for signs of damage or deterioration. Circuit breakers should be tested using a circuit breaker tester to verify that they trip within the specified time current characteristics. Eighthly, consult with a qualified electrical engineer. Selecting the appropriate short circuit and ground fault protection device for a motor can be a complex task. If you're unsure about any aspect of the selection process, it's always best to consult with a qualified electrical engineer. An electrical engineer can perform a thorough analysis of the electrical system and recommend the appropriate protection devices for the specific application. Ninthly, consider the NEC requirements. The National Electrical Code provides detailed requirements for the installation and protection of motors. It's important to be familiar with these requirements and to ensure that the short circuit and ground fault protection device complies with all applicable codes and standards. Tenthly, choose the right enclosure. The enclosure housing the motor starter and the short circuit and ground fault protection device must be appropriate for the environment in which it is installed. Factors to consider include the presence of dust, moisture, corrosive substances, and hazardous locations. Enclosures are typically rated according to NEMA standards, which specify the level of protection they provide against these environmental factors. Lastly, consider energy efficiency. While the primary purpose of short circuit and ground fault protection is to protect the motor and equipment, it's also important to consider energy efficiency. Using the appropriate protection device can help to minimize energy losses and improve the overall efficiency of the electrical system. For example, using a motor protection relay can help to detect and prevent overload conditions, which can waste energy. In summary, selecting the appropriate short circuit and ground fault protection device for a motor involves a comprehensive analysis of several factors. By considering the motor's characteristics, the load requirements, the available fault current, and the applicable codes and standards, it's possible to select a device that provides optimal protection and ensures the safe and reliable operation of the motor.